Today we are going to learn about prime factorization. First, we are going to start off with a couple of definitions. A prime number. A prime number is a whole number that has exactly two factors, one and itself. A composite number is a number greater than 1 with no more than two factors. And then we have a factor tree. This is what we are going to do to find our prime factorization. And this is a diagram that can be used to find prime factorization of a number. And our lesson, prime factorization, is every composite number that can be written as a product of prime numbers. And we're going to go more into what that means here in a second. Whole numbers are either prime or composite, but 0 and 1 are neither prime nor composite. So let's practice this. It says state whether each number is prime, composite, or neither. And we're going to find prime factorization. So here we have the number 35. Factor tree is what we are doing right here. Factor tree is finding, all the factors of the number. So we draw this little triangle, top of an arrow thing. We say, what times what equals 35? Well, we know that 1 times 35 equals 35, but we also know that 5 times 7 equals 35. When we have prime numbers, 5 and 7 are prime, we circle those numbers. Here we have what's called expanded notation, which just means we're going to write down every circled number, just so it will help us when we get to our exponential notation. Okay, so then let's go back. Factors of 35 are 1, 5, 7, and 35. So is this prime, composite, or neither according to our definitions? Well, prime is a factor of just 1 in itself. Composite is 2 or more, so it looks like we have composite, and neither is going to be 0 or 1. So since 35 has more than two factors, it is composite. Then we have this thing called exponential notation. So we write in exponential notation, well, we only have two numbers, so exponential notation is going to look like this. Moving on to number 2, we have 17. Again, we're going to start with our factor tree. What times what equals 17? Well, we know 1 times 17 equals 17. And those happen to be our only numbers. So 1 times 17, that's our expanded notation we're going to write to help us with exponential notation. Factors of 17 are 1 and 17. So is it prime, composite, or neither? What do you think? It's prime because it only has a factor of 1 in itself. So since 17 has exactly two factors, it is prime. And then exponential notation, well, we only have 1, 1, so we're going to put that in 117. So that's what our exponential notation looks like. Moving along to using this in a word problem. Texas has 254 counties, more than any other state. What are the factors of 254? And is it prime or composite? So when it's asking us this, it's wanting us to find the prime factorization, which our final answer is written in our exponential notation. So, factor tree. What times what equals 254? 254 is prime, so we should know that something times 2 is going to give us an even number always. So we can come over here to the side if we don't know and divide 254 by 2. When we do that, we get 127. Then it's trial and error. 127, you could pick 3 because 3 goes into 12 right here. But we don't have another number to multiply times 3 to get to 127 or any other number. 127 is prime. So here we have factors of 1, 2, 127, and 254. So is it prime or composite? If you said composite, you are correct. So since 254 has more than two factors, even though we only have two factors listed in here, let's look up here where we wrote all of our factors, then two factors, it is composite. And then it's asking for exponential notation. That's where we write it in expanded notation to help us with this. We only have two numbers, so we just put 2 times 127. We don't want to use 1, and we don't want to use the number we're finding in our exponential notation. Number 4 says generate an equivalent expression using prime factorization. So I would like you to try the factor tree on number 4 on your own. Once you finish the factor tree, press play to continue with the notes. Okay, now that you have the factor tree, we want to write it in expanded notation, meaning just taking all of our circled numbers, pulling them out of the factor tree to write our final answer. So we're going to start from least to greatest. We have a 2, a 2, a 2. We have 3 2's with our little multiplication signs in between, a 3, and a 5. So we use this for exponential notation. So we're going to write our base of a 2 down and then count how many 2's do we have. 1, 2, 3. So that's going to be our exponent. We have 3 2's times a 3 times a 5. And this is our final answer in exponential notation. Checking our answer. How do we know that 2 to the third power times 3 times 5 is our answer and is going to give us 120? Well, we solve it using order of operations. So 2 to the third power is 8 because 2 times 2 is 4. 4 times 2 is 8. Then I rewrite my problem. Doing the first multiplication first. 8 times 3 is 24. 24 times 5. And then 24 times 5 gives us 120. So that is how we check our answer to make sure that our exponential notation matches our original number. I would like you to try number 5 on your own. Doing the factor tree, writing it in expanded notation, giving us our exponential form, and checking your answer. All 4 things. We will check this tomorrow with our table groups. Please press play when you are ready to continue. Okay, so number 6. Number 6 says that a mockingbird has about 28 different songs that it sings. Generate an equivalent expression using prime factorization for the number 28. Prime factorization for the number 28, when it asks us this and it's in a word problem, we're going to go ahead and pull out the number that they want us to use prime factorization for. When we do that, we're going to start with the factor tree always. So I would like you to do number 6, your factor tree, your expanded form, exponential notation, and checking your answer. We will check this tomorrow with our table groups. After you have finished that, you need to write down a question of confusion. If you still have it, you don't understand something you need clarification on tomorrow in class, and if not, create a problem to solve for your table to solve.